Welcome to the part 5 of our end-to-end series. In this part, we will be introducing Kong API Gateway that will help us load balancing and create multiple copies of our backend. And Kong Gateway will automatically send our request that is coming from postman or browser or any front end to the backend based on the load, either the first instance or second instance, and we can even create more instances of our backend to provide scalability, fault tolerance, resilience, and high availability. And furthermore, why we are selecting the Kong gateway, we will be discussing in a moment. It provides many features that includes JWT authentication at gateway level, and we will be removing the code that we wrote in previous parts for passport JS and authentication. And we will also remove the code for codes, cross-origin requests, and also we will remove the code for throttling or rate limiting, and we will be using gateway for that purpose. There are several different gateways available. Like if you are working in Microsoft environment, then you can use Azure API gateway, or if you are working in AWS environment, then in AWS cloud, it gives you an API gateway out of the box. And if you want to go for .NET and open source together, you can select Ocelot for that. So let's begin our journey here. Kong Gateway is one of the most popular API gateways with free and open source versions, and considered as a leader in API gateway market at the moment in 2024. It is based on plugin architecture with hundreds of plugins that can help us addressing several different aspects. It is horizontally scalable, and we can always implement scalability, security, authentication, and authorization. There are three different ways we can configure our Kong gateway. We will be pulling Kong gateway on our machine using its container available on Docker's Hub. And the, out of those three approaches, the first one is to directly access the Kong UI from within the container using the localhost 2002, or if it is hosted online, then based on your port, you can access the Kong OSS that allows you to use a UI to configure your gateway. This is one approach of configuring it. The second approach of configuring is to use declarative approach and without database. And the third is with the database mode. We will be using that is declarative. We will not be using a database like Postgres in the background. So we are on Kong Gateway website, and if we have a look at this, it offers numerous solutions here that we can use based on our requirements. But at the time, I'm just focusing on what I need, and I'm going to documentation here, and it can give you a lot of information about how you can set up Kong Gateway in several different ways, how to install it, and getting into production. And AI Gateway, AI is talk of the town these days, so this is another interesting area to discover. So if you go to Kong plugins and have an overview about it, and then we can search different plugins. If I go to the plugin hub here, we can see different plugins available and listed here. We can select all or based on the function for which we want to find the plugin, like authentication, AI, security, traffic control, serverless, analytics and monitoring, transformations, and logging. Here, I'm going to search, for example, I just want a plugin for JWT. Rather than coding things into Node, I want to use a Kong Gateway plugin. So I can select that plugin here. And if I go inside the documentation of a particular plugin, then I can always have a look about the basic configuration and different approaches to configure. I'm using the declarative approach. So here I have basic YAML for this plugin. And if I want to add more parameters here, then I can go to configuration reference and select different parameters and their values to configure it further. Out of 100 of gateway plugins, I'll be using rate limiting, JWT, cores, and Prometheus that I configured into my TypeScript code previously, and I'll be replacing that code. I'll not need that anymore if I'm using Kong Gateway. Now we have to go one step back in this application and we need to remove anything related to authentication and authorization. Here I'm removing passport.js related code from my routes and similarly from other parts of my application. So all my routes are no more authenticating using token, and these are pretty much the same code that we used in our earlier parts. And similarly, we need to make some other changes in our application. You can see that I have also removed login, logout, register, and refresh token related code and routes. In preparatory steps, I'll be doing some changes to logging and monitoring related code. I'll be using Prometheus to actually collect matrices from Kong API gateway rather than my REST API in this example. And in case of my logging, I'll be doing some changes here. I am sending my logs to a file now using the transport.file. There is a change here, if you can see, rather than directly sending it to Loki. We are storing our logs using Winston in different files. It will be a multi-container setup where our backend application will be running in multiple containers so that we can try out load balancing using Kong API gateway. Use Promtail log aggregation, and Promtail is kind of a service that will be aggregating our logs coming from different containers, and it will serve as the middle layer between Loki and our logs. And once it collects different logs from different containers, it will aggregate and send to Loki. And then we can set up a Loki with Grafana to receive all of those logs and have a look at them. Now we need to do some changes in our docker compose.yml file. We have added two more sections here, one for Kong and one for Promtail. In Kong section, I have imported the image version that I need. I provided a container name here and then mapping the ports, internal container ports to external ports. All of this configuration is coming from the documentation. If you have a look here, I'm mapping a kong.yml file to user local Kong declarative kong.yml in my container. I'm telling that I'm using Kong in non-DB mode or DB-less mode. I'm not using Postgres database with Kong. And if I go to declarative here I have user local Kong declarative kong.yml. Log level is debug, and then I'm providing the plugins in a bundled way when I am starting my Kong server. I'm starting my Kong server as root, which you may or may not run because I'm placing the Kong in my container network. If I go to the Promtail, I'm pulling the latest Promtail version. I'm naming the container as Promtail. I'm creating a Promtail config.yaml, which I'm actually mapping to /etc promtail /config.yaml inside my container. This is another interesting line where I'm trying to allow the communication between my backend containers and Promtail container. Here I am accessing my log files from different volumes, and below here I have two different volumes that will be mapped to my containers. If I go to the top of this Docker Compose, there are a few more changes here. Like I have multiple containers running now. I've defined my backend API 1 and backend API 2. Both of them will be using my Xnode backup API 4 image, mapping it to different volumes, placing in the same network, but I am externally mapping it to different port numbers like 3001 and 3002. This arrangement will allow me to run my backend in two different containers. But in the real world, we need an arrangement where we can run large number of containers that can scale up based on our load needs and scale down when no more needed. Maybe we start with single container, and as the load increase, we can keep on adding different containers. And when the load reduces, we can keep on reducing the containers. This concept can be implemented using orchestration tools like Kubernetes. Either you run on your own machine or different clouds like Azure, Amazon, AWS, Google Cloud. They all provide managed services to orchestrate containers. Now it is time to visit Kong YAML. It will be used by our Kong container to configure and run our Kong service in a containerized way. And as we have already visited our Docker Compose, and in Docker Compose, we have seen that we are providing this file. I'm using the version 3.0 as recommended by Kong website at the moment. The schema might change in the future if you are looking at this video in the future. And if I go to the sections, there are four different sections. The first section is services, then I have upstream section, plugin section, and then the consumer section. And if I go to the top, then in this section, services, I'm defining the Kong service. It will be using different routes. At the moment, I'm just exposing customer route. I can add more routes based on my needs in this declarative approach of configuring Kong. There are even easier ways in which we can configure Kong, like we can use Kong OSS UI that will provide us a user interface to configure all of these things. This approach is good for CI/CD pipelines, so I'm using this declarative approach here. And then I have the upstream section. This backup API can actually use multiple targets for load balancing. So first target, I'm using my first container that is Xnode backup API underscore one running my REST API service in one container. And the other one is Xnode backup API 2 running in another container. And weight is defining that how we are distributing the load of request among these two different containers. And I can actually change this proportion or percentage by changing this. By 100 means I am equally balancing the load, and I can make it like 80-20 or something like that, 40-60. And if I go below, then I am using the rate limiting here. I've removed all the code related to rate limiting and cross origin requests from app.ts in my Typescript application. And now Kong Gateway will be doing all the rate limiting and cross origin request handling. If I go to cross origin requests, I'm providing my whitelisting here that I'm allowing my 127.0.0.1. I'm also allowing XOR tokens. You can visit a particular plugin's documentation to get more information about each of these parameters and what options you can use. If I go below, I have Prometheus. I'm configuring Prometheus in my code. So there is a plugin in Kong available for Prometheus. And in config section, I am enabling different matrices sets that are available in our configuration. Per consumer, upstream health matrices and latency matrices and status code matrices And I can enable few more if I like to, and I can even provide some custom matrices as well. Then in this Kong configuration, I like to token authenticate my requests before they reach to my backend. So my backend application is no more doing any security. As you've seen, rate limiting and codes and now JWT. Claim name is ISS and my secret is base 64 and I set it to false and claims to verify dash exp and runs on pre-flight true and maximum expiration 0. For the time being, my token, I don't like to expire it. I can send in my token in header as authorization, and after that I have the realm, and then I have consumer that will be used along with JWT. And in this section, I'm defining username frontend app. My frontend app will be using it, and JWT secret, that is key. And for the key, I'm providing Xnode API key. And for secret, I'm providing just hello world secret. But what you can do is you can use base64 key as well, and you can generate it on your Windows machine or Unix machine using OpenSSL rand base6432 command on your command prompt. For the time being, I'm using this hello world secret for this walkthrough, and I'm also telling that I'll be using HS256 algorithm. Now let's have a look at Prometheus. I have changed some configuration here. I'll be scrapping every 15 seconds and I'll be actually targeting Kong at 8001 to collect my matrices. I've already shown you that we are configuring the Prometheus plugin in Kong here and collecting some matrices. Now let's go to the Promtail here, and Promtail will help us to collect the log files that Winston is storing in our containers, and our Promtail agent will be collecting all of those log files from our backend containers, aggregate them, and push them to our Loki server. If you look at the Promtail configuration, we can see that we have a client section, and in the client section, we have a URL, and our client is our Loki 3001, and API v1 push. And if we go below here, then we can see that from where we are scrapping different logs, targeting my container xnode backup API underscore one, which is the container name in my configuration. Instead of providing IP in this Docker Compose setup, I am providing the container name, and similarly the other container name in the other target, and then the labels and the path from where I can collect my logs. So I'll be collecting logs from both of my instances, aggregating them and pushing them to Loki. Now we are done with our configuration. The first thing I need to do is to run npm run build to build my code. And then I'll build my container. So I'm building my backend API container after removing my security related code for cores and rate limiting and JWT authentication, and doing some changes in my log files, Winston logging. Once done, now I like to compose it. Docker compose up. Now let's verify. Now let's verify if our containers are running. So our Grafana, Promtail, Loki, Redis, Prometheus, Xnode Backup API, Kong, Xnode Backup API underscore 2, all of the containers are running. Now I need to generate a JWT token to test my Kong API endpoint that will be indirectly accessing my containers hosting my backend API. So for that purpose, I'll be using the information that I've provided in Kong YAML, especially this username, key, secret, and algorithm. So I'll be using my application key in ISS field, and subfield will be used to get back the authenticated username or email. And then I have the name, which is the name of my user front-end app in this case, and IAT represent a value that represent time when token is created, and exp represent a time when token will be expired. In case our front-end application is using or calling our endpoint, we will be using libraries to generate this token, but in my case, I will be using jwt.io to generate this token, and I will be using this token in Postman to send a request to Kong API gateway. Here is my secret, and if I go to jwt.io, you can see that I have already filled them to save time. Like I have the algorithm HS256 and type is JWT. Then in payload, I have got my ISS here, which is backend API key. And then I have sub, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Then name, which is uh, front end application and front end app. And then I have two different times, that one for time of generation and time of expiration. Then I have provided my secret here. So I have hello world secret here. It's a weak secret. Here we have the token. I'll be copying and pasting it in my postman. Now I've created a copy of get all customers here. See, the only change that I've done is I'm using port 8000, which is being used by Kong API gateway. So I'll be sending in request to API customers on Kong, and it will be redirected to one of my containers hosting my backend application. And secondly, I created my JWT token earlier on using jwt.io, and I am pasting that token in my token here. My Kong gateway service is running in container. So let me test it. Firstly, I am turning off the authorization and sending in request, and it is giving me unauthorized message. Now I'm sending in authorization key, which is the token we generated on jwt.io, and sending in the request. And here I have one of my backend containers served this request and sent out. Now I'm going to Grafana. Here, if I go to Explore, and in Explore I go to matrices and select data source as Prometheus, I can see different Kong related matrices here, and it is filling up the values. Now if I go to logs and select Loki as a data source, then I can see different messages here. Let me post another one. I'm calling my endpoint once or twice here and refresh it. I have more entries here. And now if I go to my data sources here, select explore in Loki, and in labels, let me select job and variable logs. I can see my logs here. If I actually expand one of these, I can see this request was handled by my container one. And if I go to the other ones, like pick any other one here, was served by my container two.